we're gonna go through the chapter 3 and section 9.1 and 9.2 because that is the one it will be due by next Thursday. Is that right? According to the calendar. All right, we are the 7 weeks, so yeah, a little bit faster, just you know. So let me go ahead share my screen that way. Okay, so can you see my screen? Everyone, can you all see my screen now?
Yes.
Okay, all right, good. Okay, so chapter 3 is about a probability, and some people find out this chapter is very interesting. On the other hand, some people find out this chapter is a little bit, some people consider a little bit challenging. Okay, depends on how you look at it. But you know, we just have to actually, in my opinion, as long as you understand the concept, is very doable. Okay. And this chapter combined with chapter 9, which is only 2 sections, and then that will be unit 2 test. All right. So hopefully you already started some of the chapter 3. We have a basic concept, the probability. So what's the probability? We all talk about the probability of, like I said, tomorrow gonna go about 100 degrees again, and I think the probability will be very, very, very small, right? So that is kind of probability. Or what's the probability of raining tomorrow? Okay, so maybe like a 20% or 30% chance of raining, those kind of things. So the weather forecaster is always talking about a probability, basically. All right, the change of rain, the change of snow, or change of going about 100 degrees, change of freezing, things like that. Those are all probability, right? So after this chapter, we're gonna have a little bit more like in-depth knowledge about the probability. All right. So the first section is about a basic concept and accounting in here. All right. So the objective for this section is you're gonna be able to use the fundamental accounting principle to find the number of the ways 2 or more events can occur, right? And then distinguish about the classical, empirical, and subjective probability, that kind of thing in here. All right. So the probability is an action or trial through which a specific result are attained. Okay, so the result can be through the measurement, response, or you count them. The result of the single trial in the probability experience, the result of the trial is called the outcome. Okay, and we also have a new concept here. It's called sample space. So what is a sample space in statistics here? Sample space is the set of all possible outcomes. All right, all possible outcome of a probability experiment is called sample space. Okay, sometimes we just, for short, we just call it is a all possible outcomes. So that is the sample space, right? So for example, if you flip a coin, you're gonna have either head or tail. So head and tail, this is called sample space. So we have a 2 sample space, 2 possible outcomes in here. The event consists of 1 or more outcomes is a subset of the sample space. All right. Okay, so identify sample space of the probability experiment like a broad type. You can have a O type B, type A, or AB, and then you also have a RH positive and RH negative, right? So what's the total outcome in here? So if you have a type O, type A, type B, type AB, that's 4 outcomes already. And then each one can also have either RH positive or RH negative. All right. So you can draw the tree diagram, but the tree diagram, when the number getting bigger, it can be really challenging. All right. But we do be able to draw for this one, with the tree diagram, right? So like this one, you have a type O, Okay, so we're gonna have the O, A, B, and then AB, right? So each one of them, you're gonna have a positive and negative. Each one, you're gonna have a positive and negative. All right. So each one have a two outcomes. So this is four outcome, and then this is two outcome. So basically, you have all positive, right? This is all positive, all negative, and then this will be A positive, A negative, and then B positive, B negative, right? And then the AB positive, AB negative. So this is called a tree diagram. The tree diagram, like a tree. All right. So if you count this one right here, is 8 different outcome. So how do we attain the 8 different outcome? Is 4 times 2 equal to 8. Look at that. Even I don't draw for this tree diagram, I should be able to count this one is 8. So it's 4 times the first probability is 4. The second possible outcome is 2. So 4 times 2 is 8. All right. So that is called a tree diagram. In here, you can draw for this type of tree diagram. Horizontal way, I draw for this vertical way. This one is a horizontal way, it's the same thing, right? You have a O, A, B, and AB, and then each one have a positive, negative in here. So now you have 8 different outcome. Okay, so how do I count the 8? We actually, from the first possible outcome is 4, second possible outcome is 2. So we multiply these two together will be 8. All right, so that is how you do this one in here. An event that consists of single outcome is called a simple event, right? So only one outcome is a simple event. If the outcome has more than one, it's not a simple event. All right. So tossing a head and loading a through it, you only have one outcome. So that is a simple event. All right. But if your event consists more than one outcome, it's not a simple event, right? So tossing a head and loading an even number. Well, even number can be 2, can be 4, can be 6. So this got 3 outcomes. So this one is not a simple event, okay? So if you look at this one right here, tossing a coin and a diet here. So the coin here, you have a 2 outcome. You have a head or tail, right? And then each die have a 6 outcome. So basically, you have a 2 times what? 2 times 6, you're going to have a 12 outcome, okay? So you can have a H1, the head with 1, 2, 3, 4, 5, 6, and then the tail also combined from 1 to 6. So that is 12 possible outcome, right? So I don't really have to draw for this one. I should be able to counter this one as a 12, basically. But the tree diagram can help you identify much clearly. All right, so determine the number of the outcome in each event and determine whether each event is simple or not, okay? For quality control, you randomly select a machine part from a batch that has been manufactured that day. Event A is sleeping in a specific defective machine part. Okay, so selecting a specific defective machine part, is this a simple event or not? Anyone? Okay, so if you select a specific defective machine part, if this one probably more than one, right? If it's more than one defective part, that would be not a simple event. Okay, so it depends on how many you have in here. All right, so loading a 6-sided die, event B is loading at least 4. So what is at least 4? What does at least 4 mean? So we know the die here will be, this one will be a little bit clear. Will be from 1, 2, 3, 4, 5, 6. So what is at least 4? What does at least 4 mean?
They count the first four, like more those 4. I don't know.
Okay, so at least 4, that means it's greater than or equal to 4. So that's 4, 5, and what? 6. All right, at least 4, at least also include 4. Okay, so think a lot of time people did not quite get at least correctly. Like I said, if you go to work, right, your employer is supposed to pay you at least the minimum wage. So what does that mean? That means your employer can pay you more, but cannot pay you less than the minimum wage. So does that make sense? All right, so that's at least mean. And then there's another word called at most. So what does at most mean? So like the test score, at most you can get 100. So at most is less than or equal to. All right, so at most, okay, so the test score, you if you got a perfect score, you got 100, right? The at most that you can earn is 100. So that means if you don't get all right, you're gonna earn probably 90 or 95 or maybe 80, that way. So, but the maximum you can earn is 100. So that's at most. All right. So these two words in statistics are very important in here. At least that means minimum is like at least 4, minimum would be 4, right? At least the minimum wage is the at least. At least employer have to pay you like I don't know, the minimum wage right now probably still 7.25. If the federal did not increase that way, that means so that's the minimum wage hourly. Okay, so that means the employer can pay you more, but the employer cannot pay you less than this one. If they pay you less than this one, and it's illegal unless you say you're gonna volunteer that way. Otherwise, that would be illegal. All right, so that's at least mean in here. But they can pay you like $17 or $20 or 25, right? California just trying to make all the minimum wage to $20 per hour recently. So that is the minimum wage. Okay, so that is this one called at least. Okay, fundamental counting principle is kind of if you have a false one. So if you have a false outcome is M, the second outcome is N, the third outcome is K, the fourth outcome is P, for example. Okay, so what is the total outcome? Well, basically the total outcome is multiply all of them together. Okay, so multiply all of them together. That's called a fundamental counting principle. The fourth way, in an event occurred in the M ways and the second event occurred in the N ways, then the number of ways that the two events can occur in sequence is M times N. All right, so this is not only just M times N. If you have a third event or the fourth event, you can keep multiplying together, all of them. Okay, so that is called a fundamental counting principle in here. All right, so this one, you are purchasing a new car, right? So you have this many choice. You have a manufacturer choice, the Ford, the GM, the Honda. Okay, so all those you say Honda, GM, and then some kind of automaker go on strike, that kind of thing. All right, so the car side, you have a compact, you have a mid side, and then you have all different color to choose from. So how many different ways you can have a choice for your new car? All right. So the first one, you can see the first one is 3. The second one, you have a 2, and then you have a color is 4. So you multiply all of these together. 3 times 2 times 4, that's 6 times 4, that's 24. Okay, so you have a 24 choice. So you better know which one you want before you go into choose the car, right? Otherwise, sometimes those car dealer can really mislead you, that kind of thing. I experienced several times already. All right, so you always know, do your research before you go in there, all right? Because just by this one, you have a 24 outcomes, okay? You have a 24 outcome. This is the tree diagram. So you have the manufacturer, 3 manufacturer, and then you have a compact size, and then you have a different color. So you can tell like this tree diagram is getting more and more complicated. All right. And sometimes when it's too many, it's kind of hard to draw for like more than 24 ways. Okay. So using the principle of the multiplication, we can, always put it that way. Okay. You can count them easily without dropping the tree. So this one is the access code for the car security system consists of 4 digits, right? So I usually call the digit 1, digit 2, digit 3. So you can just using D1, D2, D3, D4, that will work, okay? And then each digit can be from 0 to 9. All right, so how many access codes are possible on the first one? Okay, there's a little bit limitation. Each digit can be used only once, but not repeat. Okay, so from 0 to 9, how many total digits do we have? How many in between from 0 to 9? 10 is the correct answer, okay? So it didn't say you cannot start with 0, so that means the fourth digit, I can have a 10 choice, okay? The fourth digit, I can have a 10 choice, but it said you cannot repeat. So if I have a 1 out, okay? If I choose this one is 8, for example, and then 8 is out. So how many left for the second digit? Will be 9. Is that right? Because 8 is out. This number 8 is out. So you can just choose from 0 to 7 and 9. So that's total is 9. So if I choose the second digit is 1. So now the third digit, I cannot choose 8. I cannot choose 1. So how many digits left for the third one?
Would it be 2? Or 8
No,
again?
you exclude 2. You have a fourth digit. We're gonna just say, for example, this one right here. This is an example, okay? So the fourth digit, if I pick 8, because the fourth digit you can have anything, 0 to 9, which is 10 total. So you can choose anything. But given the first one is already taken, the second one you only have a 9 there, right? And then if I choose this one is 1, now the third digit I only have 8 there. And then if I choose this one is 0, 0 is out. So 1, 0, and 8 is out. So fourth digit, how many left I can choose for the fourth digit? 7, right? So now you have a 10 times 9 times 8 times 7. So you can go to give you a quick calculation to see how much is that. Anyone give you a quick calculation? All right, so we have a 9 times 8 times 7, that is 504, and then times 10. So that's 504, 0. So you have a 5,040 choice for each digit can be only used once, not repeat. Okay, that is the A. That's the first one. Okay, so second one, so each digit can be repeat. So how do you find the second one? Each digit can be repeat. Well, so 1, 2, 3, 4. Each digit can be repeat. So that's the second one. So the fourth digit, how many choice you have? 10. Is that right? We just say from 0 to 9 is 10. 10 of them. Okay. So since this one you can repeat, so how many digits you can for the second one? Well, each one gonna be 10 because you can repeat. So that is 1, 2, 3, 4, 4 tens multiplied. So that's 10,000. Look at it. If I cannot repeat, I only have a 5,040 choice. If this one you can repeat, well, if you can repeat, everyone can have a 10. All right, so 10 times 10 multiplied together, four tens multiplied together is 10 to the 4 power, right? So that's 10,000. Okay, let's look at number 3. Let's see how do we do the number 3 in here. Number 3 got a little bit limitation. Each digit can be repeat, but the fourth digit cannot be 0 or 1. All right, so now how do we do the number 3? So the fourth digit cannot start with 0 or 1. So that means how many choice do I have on the fourth digit? Well, you have a 2 number is out. I cannot be either 0 or 1, right? So now I have a 10 digit. I have a 10 choice minus 2. So how many choice I have? I only have 8 choice. I can only choose from 2 to 9. Okay, that's the fourth digit. All right. And then how many choice do I have for a second one? Each one will be 10 because you can repeat. So we have 8,000. We have 8,000 possibility for this one. All right, so that is how you do this one. You just have to figure it out how many possible outcome for each one. All right, so this is cannot be 0 or 1. If I change this one, say the fourth digit must start with 0 or 1. Now this will be only 2 choice, right? You only start with 0 or 1. But this one is said cannot be 0 or 1. So cannot be 0 or 1. That means you can still have a 2 to 9. So you still have 8 choice in here. Okay. Any questions? All right. So that is the counting principle. All right. So how about like a license plate? Okay. I'll give you another example. Like a Texas, you have a car license plate, right? License plate, usually you have a, like I said, 2 number and then 3 digit. Okay, so if I say the first number you must start with either T or X. I'm gonna say this is Texas. So the first license, the license plate start with like I said, 2 letter and 3 digits. Okay, how many possible outcome do they have? And I want the first letter start with either T or X. So that means the first choice, first letter is only have a 2 choice, right? And then what is the second letter? Second letter is it didn't have a limitation. So what is a possible outcome for the second letter? So you have alphabet from A to Z. How many outcomes? That is 26. Okay. And I didn't say anything about a digit in here. So if we didn't say anything, we can assume you can repeat. All right. So how many possible digit for the D1? Each one will be 10, right? And then we just multiply all of them together. So this will be 52,000. 52,000. Look at that. So if I want the first letter start with either T or X, that means I only have 2 possible outcome. All right, the second letter can be anything. So that's 26 from A through Z. All right, and the digit you can repeat. So each digit gonna have 10 possible choice. So you multiply them together. So you're gonna have 52,000 possible outcomes. All right, so that is called a basic counting principle. Okay, the probability, which the probability here, now we're talking those are just the total counting principle, all right? Total number is not a probability, it's just the total possible outcome, all right? Now we're talking the probability, which you have to, using the number of the outcome in the event E, you have to divide it by the sample space. So we just mentioned earlier, what is a sample space? The sample space is all possible outcome. Okay, sometimes we call it is a total. So you're using the number of the outcome divided by the total. So that will become the probability. So probability is kind of like a percentage. You can change it into percentage, or you can put it in the decimal point, because the probability is between 0 to 1. Okay, always using positive number, but if you want to have a percentage, usually say 30%, right? We usually hear from the forecast and say, oh, it's gonna be 30% rain tomorrow. So that's 30%. What does 30% mean? Well, 30%, if you convert it into zero, is 30 divided by 100, so that's 0.3. All right, 0.3 is between 0 and 1 in here. All right, so sometimes we don't hear the forecast and say, oh, there's a 0.3 chance of raining, right? They always say 30%. All right, so now you know 30% actually is just 0.3 for the probability in here. All right, so look at this one right here. This is a 6-side die. Find the probability of each event, right? Loading a 3. Well, how many possible? So find the probability of loading this one. So probability of loading a 3, we have a 1, 2, 3, 4, 5, 6. So there's only 1 3 here. So that's 1 out of total. Total is what? 6. All right. So it's 1 out of the 6 chance you're gonna getting a 3. All right, probability of getting a 7, loading a die, loading this 6-size die. Well, there's no 7 right here, so the possible outcome for 7 is 0, right? So 0 divided by 6 is still 0. Okay, probability of landing a number that is less than 5. Well, less than 5 didn't include 5, right? This is not less than or equal to. It's a less than 5. Less than 5 is less. Do not have an equal sign. So you have a 1, 2, 3, and 4. So that's 4 out of the 6. Okay, but you cannot put it in the computer. You cannot put it in the mind math to say 4 out of 6. You have to simplify. So this is gonna have to simplify into 2 over 3. Or if you convert it into decimal point, usually it will ask you to run to 3 decimal point or something like that, right? Now you can use a computer to run to 3 decimal point. It's with 0.0006, keep repeating on 6. So if I run to 3 decimal point with 0.667, okay? Otherwise, you type the exact answer. This is called the exact answer. All right, exact answer, you always have to simplify. You type a 4 over 6 in there, it won't counter you. It will counter you wrong. So you have to simplify. Simplify into 2 over 3. Okay, top and down can be divided by 2. All right, so that is the probability, and we can tell this probability here is less than 1, right? And it's greater than 0. So that is the probability in here. Okay, any question, you always have to divide by the total, the total, the sum of the total possible outcome. So it's 1 out of the 6. Okay. All right, so we're gonna talk called the empirical rule. The 3 different type of probability. One is called a empirical rule or statistical probability. It's based on the observation obtained from the probability in the experiments. Okay, relative frequency of the event here is using the frequency of the event f, right, divided by the total frequency n. So the total of the frequency n is also equal to the sum of the frequency. So this is called a total, or in our word earlier, it's called sample space, right? We just learned a new word called sample space. So with the sample space is the total of whatever you have here. All right. So look at this one right here. One thing, the empirical probability, right? This one is a book reading by US adult. Determine how they read the book during the past year. Okay, so this many 1,490 adults have been surveyed. So that's the total. So this is our sample space. Okay. 1,490 is a total being surveyed, so that's the sample space. Okay, this pie graph showing like the number for the book read in each one. All right, so what's the probability that the next adult survey read only print word during the last year? Okay, they probably do not read any ebook or something like that, just the printed word, the book. Okay, so now we go to look at the, some people, this many say they don't read any book. This 5, 7, 8 read a print word. Okay, so it's 5, 7, 8 out of this many. All right, so this is the probability of the print, reading the print book in here. All right, so you can convert it into decimal point, or you can either convert it into decimal point or okay, some chat. Student waiting in the room. Okay, let me see. Where am I? Okay, usually students can come in on their own, and I think I admitted that earlier. I did admit one earlier. If you log into the Canvas and click on that, you will be able to log in, directly. So without me having to admit anyone that way. All right. Okay, so this way you can either you can put it in a calculator. All right, so okay, so that is okay, so that's what I like that you say. Look at that, it can run that directly for you. All right, so if I need 3 decimal point, it will run that for you. If I need 4 decimal point, it will run that for you directly. Okay, so that's 0.0 388. All right, or you can multiply by 100%, that's 38. Or if you run to the integer for the percentages, yeah, that's about 39%, okay? Around 39% of the people only read the printed words, print books, okay? Only read the print books. And that's, you can see how many did not read at all right? And only 91 said that they read the digital books, okay? I think a digital book are getting more and more like popular. This was the survey, Pew Survey, which is a very famous research center. That was back in 2016, right? If you survey in 2022 or something, I'm sure this digital book will increase. Okay, but that is how you find the probability. Okay, any questions so far? Anyone has any questions? Okay, so the total here is 1490, right? And then you using the 578 divided by the total, they're giving you the probability in here. All right. So that is called empirical probability. This one is a table. Okay, this is a distribution table. The age. This company is conducting a phone survey of randomly selected individual to determine the age of the social networking site user. So this many, so you don't really have to add it on your own. It tells you in here already, this is the total, right? This is, so if you go to add this together, it's also giving you the 975. But why you have to add if this question already told you here, all right? Okay, the frequency distribution showing in here, right? So we're gonna find a probability of next survey between 23 to 35. So this is 23 to 35 in here. All right, so what's the probability for this age group? A probability you using the F over N. N is the sum. The sum is 975, right? And then this one is 312, age 23 to 35, 312. And then you just go ahead and divide this one and find the answer, okay? So actually it's pretty straightforward that way. All right, I also want to introduce called the law of large number, right? I usually, when I have a class, in-person class, I usually tell students, say, if you flip a coin, a penny, if you flip a penny 10 times, do you got exactly 5 head or 5 tail? Well, I usually like that group of people. You can do this one on your own at home as well. You can flip a penny, trying to do that 10 times and then record how many times you got a head, how many times you got a tail. All right, and I usually got a different result, right? So I have a head, I have a tail, and then we find the probability of the head, right? So we have n equal to 10, right? So you flip the coin, the penny 10 times, and then we have a group 1, group 2, and then group 3, and so on, right? So I'm not just using 3. So for example, if the first group got 5 head, 5 tail, now we have a probability of the head is 5/10, right? So 1/2. All right. And that is usually called a theoretical. If I don't ask you to do the experiment, I just ask you, if you flip a penny, what's the chance of getting a head? Well, usually people say, yeah, 50%, 50% of the time you're gonna get a head. So that's 1/2, right? Half and half. But actually, when you do the real experiment, not every group will get a 5 and 5. Some of the group get a 7, some of the group got a 6, some of the group may even got a 4. Okay, so and then that means the tail will be 3, this is 4, this is 6. So what's the probability of getting a head here? So now this will be 7/10, right? And then this probability of getting head will be 6/10 or 0.6. This will be 0.7. This probability of getting a head will be 4/10, will be 0.4. So you can see it's not always 0.5. Okay, it's not always 0.5 that way. But why we say, if I ask you, what's the probability of getting a head when you flip a penny? People always always answer, say, yeah, half and half, which is 50%, right? And this 50% is according to the theory in a perfect condition, okay? In a theoretical, because think of the theoretical, we only have the head and the tail, right? So probability of getting a head is 1/2. So that's called a classical probability. Classical probability is also called a theoretical probability. All right, but if you ask you to do the flip the penny 10 times, this is called a empirical probability. It's according to the real experiments. So that's it, according to the real experiment. Oh, all right. And that one sometimes a little bit different than the classical probability. But if you flip the coin many times, not just 10 times, if you flip the coin on the raker, it's 68 million times. 68 million times. That is a lot of times flipping. All right. If you flip the coin 68 million times, guess what? It's gonna get him very, very close to 50 and 50. All right, so that is called the law of large number. Okay, as an experiment is repeat over and over again, like on the raker, flip a penny 68 million times. The empirical probability of the event opposed to the theoretical or the actual probability of the event, or the theoretical, we also call the classical probability. All right, so that is called the law of the large number. If you flip the 68 million times, you're gonna get him very, very close to the 50 and 50% of the head and tail. All right, but if you only do this experiment 10 times, that's why we did it in class before. We always got all kinds of different outcomes, right? Some people even say they only got 2 head at one time. All right, so that's called the law of the large number. Subjective probability is based on the educated guess of estimate, right? So a doctor might feel a patient has a 90% chance of the full recovery. Well, because the doctor going through the medical training, so they can kind of estimate that way, right? So that is called a subjective probability, that kind of thing. All right. So this is based on educated guess or the estimate that way. All right. And this subjective probability, of course, 90% not always correct, right? Maybe sometimes more than 90% will get a full recovery, and depends on the patient's physical history, right? Some people got a 90%, some people probably got 95%, some people might just got 80%, right? If you have a same injury, but depends on the person's history, they might have a different percentage. But that is the doctor's best guess, okay? So that is called a subjective probability. All right, so we have 3 different type of the probability in here, okay? The probability that will get you this one is classical or empirical or subjective probability explain the reason. So the probability that you will get an A on the next test is 0.9. What do you think of this one? What kind of probability is there? Well, this is kind of like the professor look at the students' performance, right? If the person did the homework on time, complete all the homework, attend the class, the chance they're gonna get an A is much higher than those who did not complete the homework on time and absent from the class, those kind of thing. All right. So that I think this is based on the educate guess, right? Because we don't do any different to the students, so it's not a experimental that way. All right. So that would be the good example for the subjective probability. Okay. All right, so look at it. The probability that a voter choosing at random will be younger than 35 years old is 0.3. What do you think of this one? The voter choosing at random will be younger than 33 years old is 0.3. All right, I would say this one would be based on the empirical probability, that probably based on some kind of result from the past, right? The result from the past, that means they already have a statistic for that. Okay, so I would just say this is mostly like the empirical probability, that kind of thing. All right. The probability winning a 1,000 ticket raffle with one ticket is 1/1,000. Well, this one will be a perfect example called a classical probability, right? So, that is 1,000 ticket raffle, and then you buy one ticket, so that's 1 out of the 1,000. That's how you counter the classical probability. Okay, so that is kind of a probability you cannot be able to classify that way. As I mentioned earlier, probability is always between 0 and 1, okay? We don't use a negative number for the probability. We don't use anything more than 100% for the probability, all right? So what does 0 mean? 0 means impossible, okay? That means it's nothing going to happen. It's impossible. Anything less than 0.5 is unlikely, right? And that's the even chance, okay? 50-50, you heard of that. And then anything more about 0.75 is called likely, right? Or 0.9 called very likely, right? And 1, that means 100% going to happen. So that's certainly going to happen. So that is how you use the probability to describe a certain event, that kind of thing. All right. If we say the rent chance is 30% tomorrow, so 30% will fit into like an unlikely category, right? That kind of thing. All right. So it's not impossible, but unlikely. Okay, 30% chance of rain is kind of a little bit unlikely to rain, but it's not impossible. So it still have a little bit of hope, that kind of thing. All right, another one is called a complementary event. So we use E prime, so we have a sample space. Sample space is a total, right? So that's my total. And then I have an event E in here. And then everything outside the event E is called a complementary. So the event E and the complementary, the probability of the event E and the complementary add up together always equal to 1 or 100%, right? So if I know the chance of raining tomorrow is 30%, what is the chance of not raining? So the chance of raining tomorrow is 30%. What is the chance of not rain tomorrow? Well, it will be 1 minus 0.3. will be 0.7 or 70% of the chance, or you can use 100% minus 30%, right? So that will give you 70%. So if we say the rain tomorrow is a 30% chance, the chance of not rain tomorrow will be 70%. All right. So if I know one of them, I can calculate the other one easily. Okay. So that kind of thing in here. All right. So that is called a complementary. This one cannot stay that way. Let me erase. All right. So okay, I have to figure out this one later on. Okay, so let's look at using a tree diagram in here. Let me go ahead open the other one so you don't bother by this one right here. Okay, so let's look at this one right here. It's a find a probability. Find a probability randomly select a social networking user who is not 23 to 35 years old. Remember, it's not. Okay, so what is not in here? It's not. So we have a 25 to 35 is three 12, right? And if it says it's not, so you have to read this one carefully. So it's not. So it's not, that means include here, here, and here, and here. All right, just exclude this one. So you can go to add all these four of them together, or I can just using, if we already calculated the probability of 23 to 35 earlier, I can just using 1 minus 3.1to over 9.75. Okay, so using 1 probability of not 23 to 35, I can using the total probability just minus the probability of 23 to 35. Look at it. So that's called a complementary. Okay, this one not 23 and 35. I can just using the total minus 23 and 35, and I will get the rest of them. All right. Or in this case, I can go to add all this together. 156 plus 254 plus 195. Okay, plus 58. And divided by the total. I can using the if I don't want to use the complementary, right? I can use this way as well. But you can see this calculation is much more, a little bit more calculation than this one. Okay, so that is the beauty of the complementary. You can do that one much easily. All right. Okay, so using a tree diagram, the probability experiment consider tossing a coin and spinning a spinner, showing the spinner is equally likely to launch on each number, right? Using a tree diagram to find the probability of each event. Event A is tossing a tail and spinning an odd number. All right, so now you need to say what is the odd number? Well, the odd number can be 1, 3, 5, and 7, right? So 1, 3, 5, 7, those are the odd numbers. So how many odd number in here? Well, we got 4 odd number in here, right? And then the probability, this is the tossing a coin. The coin can be either head or tail, okay? All right, so, and then the B here is tossing a head or spinning a number greater than 3. So what is greater than 3? Well, greater than 3, that means greater than 3, that means 4, 5, 6, 7, and 8, right? This is from 1 to 8. All right, so greater than 3 did not include 3. So that is this one. Okay, so you can go to drop a tree diagram. This is a head and tail right here, right? So you have a head, you have a tail. And each one gonna combine with 8 number, each one combine with 8 number. And then we want a tail. We want the first one is a tail and an odd number. So the tail and the odd number. So we have a T1, T3, T5, T7. So that is the event A, you have a 4 outcome, right? So you have a 4 outcome. So that is 4 divided by the total. So what is my total? Well, I have a first one is 2 outcome. I have a second one is 8 outcome. So my total is 16. Look at it. So in order to find the probability, I have to find the total. So simplify this 1 out of the 4 or 0.25 that way. Okay, so that is the probability of tossing a tail and spinning an odd number. So you can find that from the tree diagram here very clearly, and then you can count the total. That is A in here and then A in here. Total is 16 outcome, right? 16 outcome in here. Okay. All right, the second one here is what? Where's the second one? Tossing a head or spitting a number greater than 3. Okay, so tossing a head here, this is a head, or a head, or that means, can be either one. So this a head here is, everyone here already got a head. So you have 8 different outcomes, or a number is greater than 3. So we have a 4, 5, 6, 7, and 8. So that is A plus 5, that's 13 outcomes, right? This is or. Or that means it can be just either one, not an n. All right, in here. So now we have a 13 out of the 16. So this will be 13 out of the total is 16. Okay, we have 13 outcome. Out of the sample space, the total is 16. All right, and then you can divide by this one. You can have a 13 divided by 16. You have 0.813. 0.813 outcome. All right, so now you can see all these probability are greater than 0, less than 1, right? Probability can only be greater than or equal to 0. Always check your probability to see if it's greater than or equal to 0 or less than and less than or equal to 1. Okay, you cannot, if you calculate this one as 8.13, that can be wrong. All right, so that is the probability for the first section. Okay. Any questions so far? All right, so that's the first section. We have a few more section to go. The second one here is conditional probability and the multiplication rule. All right, so we have to know what is the conditional probability. So that means you have some kind of condition, right? I usually giving people a little bit like I say, if you got a flu shot and you still have a probability of getting flu, right? So that is the condition. Giving a person already got a flu shot, but the probability of getting the flu will be smaller, okay? But still have a certain probability of getting flu. All right, so that is called a condition, right? Giving something already happened and another thing still happen. So that's the condition. All right, and the multiplication rule, we're going to talk about later in here. So how do you find the probability given of an event that another event has already occurred? Okay, and then how to distinguish between a dependent and independent event. All right, and then using the multiplication rule to find out. Okay, so condition probability, we're using this symbol. All right, so using this symbol, P of B giving A. So this is reading called probability of B giving A is already occurred. All right, probability of B, probability of getting a flu giving, you already got a flu shot. Okay, so that is probability of B giving A is already occurred. All right, so let's see how do we find this type of probability. That's why sometimes the people, in this chapter, you have to read the question very, very carefully, okay? Two cars are seated in a sequence from a standard car. So where's a standard car here? Standard car, that means usually don't include joker. So that's called a standard car. All right, some people say, I never play car. Do I have to do this kind of question? The answer is yes. If you do not play the car, I think I have usually I post this one on the course. You can have a picture of standard car. Look at this one right here. Okay, so that is the standard card. This is how the standard card look like, right? You can print out. Some people say, yeah, you can print out this picture for your homework, for your quiz, that kind of thing. All right. So you have 4 different colors, right? Each set is each one is 13 from A, from 2 to king, and then you have an A in here. All right. So you have a heart, you have a space, you have a club, you have diamond in here. All right. So that's called a standard card, right? And usually the jack, queen, and king is also called face card. This is only the card has a face. Okay. So this is sometimes the question also called this is a face card. All right. So just FYI, you can have you can print out if that help you for the question. Okay. So for the probability, so the 2 cards sit in a sequence from standard card, right? So that means you pick 2 cards out. Okay. For the probability, the second card is a queen. Given the first one is a king. Assume the king that is not replaced. Okay, so that means if the king is out, that means you have 1 card less already. All right. So now this is called condition probability, right? So 2 cards there in a sequence. All right. Given the first card is a king. Okay, how many king is there? We have 4 kings. And how many queens are there? We also have 4 queens. Is that right? We also have 4 queens. Okay, we also have 4 kings in here. As you can tell, I just showed you the picture earlier, right? So that is the queen. Q is the queen. The king is in here. All right, so what's the probability of getting a queen? Apparently, the queen here, you got 4 queens, right? 4 queens in here. If we didn't, if I only ask this kind of question, what is the probability of choosing a queen in a standard card? That'd be a little bit easier, right? Because we have 4 queens right here. Out of the total is 52. Okay, so 4 out of the 52. That is the probability of choosing a queen. All right, but this is a condition. Condition is giving a king is already taken out. All right, so the king is already taken out. That means how many is still there? Well, king is out, only a 51 there. Okay, and I still have 4 queens, so it's 4 out of the 51. So that's the condition. Probability of finding a queen is giving king is already out. Okay, so that's 4 out of the 51 because 1 card is already out, not replaced. So king is out. 1 king is out. You only have a 51 total, right? And then 4 of them are queens. So that's 4 out of 51. All right, so that's called a condition probability. Okay, so look at this one. For the condition probability, this table showing the result of the survey of these many social media users will ask whether they have been offended by something they saw on the social media. Okay, so for the probability that is male, all right, probability that is male, given the user was offended by something on the social. So probability for the probability that is male, okay, so given the user was offended, that means the answer yes. So that means we only look at this column in here. All right, we are not looking at the whole total. We only giving this condition the user said was offended. All right, so we only look at this offended column in here. So the probability of getting a male given this one was offended. All right, so the offended here total is 1151. All right, and how many males are here? 532. So that is the percentage of the probability of the male. Okay, that was given the condition was offended. All right. So that is called a condition probability. Okay, so if you look at the total here is 1151, right? And the male is 532. So you're using 532 divided by 1151. So that is the probability of a male given the condition that is offended. All right, dependent and independent event. If two events are dependent on each other, that is called dependent event, right? The occurrence of the first event does not affect the if it's not affect the probability of the second event, that would be called independent, right? Events are not independent, it's called dependent. So that is kind of that means event A affect event B, that would be called dependent, right? Event A happen doesn't affect event B happen, that's called independent. So some people say, I go to the gym every day. Well, compared to your statistics score, if you go to the gym every day and then will that affect your math score? Well, I would say those two are pretty much independent. Okay, you go to the gym every day, and then it doesn't really affect your math score. But if you say I go to the tutoring center, I go to the math tutoring every day. Okay, we have a math tutoring center in all the TCC campus, right? So if you say I go to the math tutoring center every day and you math score, that would be called dependent, right? Because if you go to get a in-person tutoring, I'm sure your score gonna be much higher. It will help. So that's called a dependent in here. All right. So the independent, the probability of the B giving A is equal to probability of B because they don't affect each other, right? So same thing, probability of A giving B is already happened. It's also just equal to probability of A because the probability of A doesn't affect by B. This doesn't affect by A. This doesn't affect by B. So still equal to itself. So those are the independent, okay? All right, so look at this one right here. Determine the event are dependent or independent. So the first one, A, you choosing from a standard deck of the 52 playing card, not replacing it, and then selecting a queen from a queen B from the deck. So is this dependent or independent? Well, if you choose the card and not replacing that, right? And then selecting the queen, of course, this is a dependent, right? So because you didn't replace that, think about it. If I do not select the king from this 52 playing card, not replacing that, and then selecting a queen from the deck, you're not replacing that, so you affect the probability of choosing the queen because you got one less already. So this will be the dependent event. All right, it affects the outcome, so that's a dependent event. Okay, so determine this one, tossing a coin, getting a head A, and then loading a 6 dice and attend a 6. So what do you think A and B? Is this dependent or independent? Can anyone give a little bit answer for this one, dependent or independent? Will the event A affect the event B? I would say probably not, right? Because you tossing a coin, get a head or get a tail. This is a different one. Two different different object in here. So this you flip get a head or tail. It doesn't affect this one. You're gonna get a 6 or 1 or 2. So I would say these two are independent. Okay, this event A doesn't affect event B, so that's independent. Okay, we're gonna look at the multiplication rule. Okay, so multiplication rule, you have to look at this is dependent or independent. If you have a and B, so sometimes the people say, how do I know this is a multiplication rule or addition rule, right? Later on, we're gonna talk about addition rule as well. So the problem here is if you have an N, usually it's the multiplication, okay? The probability of A and B, you have an N here is using the multiplication. So A and B is the probability of A times the probability of the B, given A is a curve, if this one is dependent, all right, in here, if this is a dependent. If this is an independent, a probability of A and B, you just multiply A and B together, probability of A and B together for the independent. Okay, so let's look at this one right here. Two cars are selected without replacing the fourth car. Okay, without not replacing the fourth car. From the standard of 52 playing card, for the probability selecting a king and then selecting a queen. Okay, and so we're gonna have a first one probability of selecting a king and then selecting a queen, right? So according to this one right here, this is the probability of the king times the probability of the queen, given king is already up. Okay, so that is the N. Find the probability of selecting a king and then selecting a queen. All right, so we know there's a 4 king there, right? So probability of selecting a king here is 4 out of 52. Okay, probability selecting a queen, we also have a 4 queen. But given the king is already out, not replacing that, without replacing the first one. So we only have a 51 left. So we only have a 51 left. So that is how you do this one in here. Okay. All right. So that is called dependent event. Second one here, the coin is tossed and the die is loaded. To find the probability of tossing a head and then loading a 6. And then loading a 6 in here. All right, so how do you do this one? So the probability of getting a head, okay, since this one is independent, so probability of getting a head and loading a 6 will be equal to probability of the head times the probability of getting a 6. So it's independent. So I just need to multiply those two together, right? And probability of getting a head this is a penny, so it's 1 out of 2. Okay. Probability of getting a 6, I have a 1, 2, 3, 4, 5, 6. I only have a 1 6 there. So it's 1. There's only 1 6. And out of the total here, the total here is 6. So that is 6. So multiply these two together, we have a 1 out of the 12. Okay. So you have a 1 out of 12 chance that you're tossing a head, you're tossing a coin and loading a dice and get a head and then loading a 6. So you have 1 out of the 12 probability. All right. So that is giving you the calculation of the probability in here, okay? Giving you a little bit look at what is dependent and independent event, all right? Using the N. Okay, we're gonna look at the third section in here. Okay, the third section here is called addition rule. Okay, the addition rule. we just said it earlier, when you use the addition, when you use the multiplication, right? Multiplication is you see something using n, okay? Probability of A and B, probability of A and B, okay? You're gonna using the probability of A times the probability of the B. If this is the dependent, you're gonna have to have a probability of B given A is already happened. If this is independent, right, you just using probability of A times probability of B, because the independent probability of B given A is already happened. It's just equal to the probability of B for the independent. Okay. All right. So when you use the addition, it's something you have or. Okay. Probability of A or B, you're gonna using probability of the A plus probability of B. All right. So that is the or in here. And then same thing, you also have a two scenario in the addition. So is mutually exclusive or not? We're gonna talk about it in a second. All right. So we're gonna have to determine if two events are mutually exclusive or not. And we need to be able to find a probability for those kind of situation, okay? So what is a mutually exclusive and not mutually exclusive? Look at this Venn diagram here. This Venn diagram, if you have A has nothing to do with B, this is called mutually exclusive, right? Like I said, you go to the gym and you study math, okay? So those are independent. Okay. All right. Like I say, that is not a good example for this mutual exclusive. Like I say, if you are a math major and you are a history major, right? So what's a math major and a history major? Well, you know, and you want to count how many students major in math, how many students major in history, right? So those I would say mutually exclusive, because math and history, you know, you cannot measure math and also measure history. If we say major can only have one major, okay, that kind of thing. All right, and then this one you say if you are being a male and major in nursing, okay, so if you are male and major in nursing, male can also major in nursing, right? So that kind of things, this is not mutually exclusive, because you can be a male and also major in nursing. Actually, in our class, I think that I usually, in my statistic class, I always have one or two, male students also major in nursing, that kind of thing. So that is called not mutually exclusive, okay? All right, so look at this event in here, loading a 3 in a die, loading a 4 in a die. Well, 3 is 3, 4 is 4, right? So there's nothing in common in here. So this is called mutually exclusive, right? You're loading a 3, you can just count the 3. Loading a 4 is a 4, right? This one right here, see that a male student and a nursing major, which I just giving you example earlier. You can be a male student and also major in nursing. So this is not mutually exclusive. All right. Okay, broad type. Randomly select a broad donor with type O. Randomly select a female broad donor. Well, you can be a female also and type O broad. So that is not mutually exclusive, right? Mutually exclusive, that means if you are type O, you cannot be a female. And there's not such things. All right. You can be a female and also a type O, person that way. All right. So those are called not mutually exclusive. Okay. All right. So now we knowing that mutually exclusive or not mutually exclusive, we need to be able to calculate, right? If this is mutually exclusive, let's start with the easy one. If this is a mutually exclusive event A and B, the probability, look at it, this is using or. So using or, you need to use the addition, right? If this is mutually exclusive, you just mutually exclusive, you have A, you have a B right here. So probability of A or B, you just add these two together. If this is not mutually exclusive, now you have an A here, you have a B here. So if you add A and B together, guess what? If you add an A in here, this part already include in A. If you add a whole B together, this part you also include in B. So basically, you just add a middle part twice. if this is not mutually exclusive, you just add the middle part twice. So that's why you have to minus the middle part A and B once. Okay, that's the probability in here. So do not overcount. All right. Okay, so let's look at this one right here. Using addition rule to find the probability. You select a car from the standard deck. Find the probability that a car is a 4 or an ace. Well, you can see from this car in here, okay, I still have a car open. A 4 in here, okay, so this is a 4. So 1, 2, 3, 4. We have a 4, 4, right? Or an A is right here, okay? A is also right here, so there's nothing over there. All right, so you just add these two together, so you have an A total. All right, A total in here, A out of the 52, right? Probability of, so this is how you write. Probability of 4 or A, since this is mutually exclusive, so we're gonna have a probability of 4 plus probability of getting an A. And that's 4 out of 52. This is also 4 out of 52, right? So we have an A out of the 52. Simplify that, okay? All right, so that's one thing. Sometimes the people say, I do not know how to simplify. Let me show you, if you do not know how to simplify, you can do that in a calculator, okay? Do this one in a calculator. It's really easy. Calculator usually simplify for you. Although if doing the statistic, you should be able to simplify, but sometimes the number getting a little bit bigger. And some people say, well, I divide by 2 and still not enough. Well, I still have to keep divide, right? So you can just do this one really quicker in the calculator. Okay, that's 8 out of 52, right? 8 divided by 52. Okay, so this is 4 out of the 13. But when you hit enter, the calculator usually giving you the decimal point. All right, and you go to math, and then the first one is a fraction. That means I just hit enter. So that means to flip this decimal point into fraction. Oh, that's 2 out of 13. All right, yeah, not 3. 2 out of 13. So look at that. This is the same thing. So if you add out the 52, simplify, divided by top and down by 4. So 8 divided by 4, you got 2. 52 divided by 4, you got 13. So that is simplified. The calculator always retain a simplified format, so it'll be 2 out of 13. Okay, so that one you can simplify that really quicker that way. All right, so we have this simplify here is 2 out of 13. Okay, because usually they usually ask you to keep the fraction, the exact answer. So fraction is the exact answer. All right. Okay, so this one right here is loading a die, find a probability, loading a number less than 3, or loading an odd number. All right, this is all. So the all in here, remember you have to using the addition. So loading a number less than 3 or an odd number. Okay, so if we using a number less than 3 plus all the odd number, guess what? You want, if you count the number is less than 3, right? Loading a number, a die is from 1, 2, 3, 4, 5, and 6. Okay, loading a number less than 3, so you can have 1 and 2. So if you count the 2 out of the 6 and an odd number, you have a 1, 2, 3, 3 out of the 6. You just counted 1 twice. Look at it, you just counted 1 twice. Okay, so you counted 1, so you have to minus 1 over 6 once, so you don't overcount. All right, because you counted 1 is less than 3, also counted 1 as an odd number. So if you use this one right here, you just counted 1 twice, so you have to minus that one. Okay, so you have a 2 plus 3 minus 1, so that's 4 out of the 6, simplify 2 out of the 3. Okay, always simplify your final answer in here. All right, so that is how you do the probability. Okay, I have to figure out this one right here. Why this one don't let me erase? Hmm. Okay, so a little bit challenging in here that it didn't let me erase the question I have earlier. Okay, so I'll open this PDF. Okay, so this one is the funding probability of the mutually exclusive event. Okay, so why this one is a mutually exclusive event? Because this is frequency distribution showing the volume of shares in dollars and the number of the months in which sales representative reach each sale level during the past 3 years. Okay, using this share pattern, find the probability that a share representative will sell between 75,000 to 124,999 next month. So we can tell like a 94 between 94 and 95. That's between 94 5 to this one right here. Is that right? So that is this one n and this one. So that means we're gonna add these two together. All right. From here to here. So we have a from this is 7, from this is 9. Okay, so that means I will add a 7 and 9 together. Okay. All right, so let me go ahead and write down on my this one PDF. Don't let me write in here. Oh, I can using the Excel. Okay, let me go ahead using Excel. All right, so we have a total here will be 9 plus 7 will be 16, right? 16 divided by the total. So how much is the total in here? I don't know the total, so I can add all of them together. So the total here will be 3 plus 5 plus 6 plus 7 plus 9 plus 2 plus 3 plus 1, right? So that is my total in here. All right, so I have a 16 out of this total will be 0.444. Okay, so the probability using this pattern, because this is mutually exclusive, so that means 7 is 7, 9 is 9. This do not have anything over there. So I just add a 7 and 9 together, which is 16. All right, so 16 divided by the total. Okay, so that we are giving you the 16 divided by the total. That we're giving you the probability. All right. So that is how you find this type of question in here. Okay. All right. We have a 7 plus this 9 together, and then we divide it by the total. Okay. Look at this broadband catalogs of the broad type. Okay, where I is positive, I is negative. Given on the last 5 years, this is we want to find the probability the donor has type O or type A blood. Okay, so type O and type A, these are mutually exclusive. Look at it. If you have a type O, you cannot have a type A. All right, so that is a mutually exclusive. So we're gonna add these two together and then divide it by the total. All right, so that would be the type A or type B. So type A or type B, you have a 184 plus 164, right? So that's 348. And then the 348 divided by the total, which is 409. Okay, the total here is 409. All right, so then we're giving you 0.85 or about 85% of the people have either type O or type A blood. All right, because that is mutually exclusive. Okay, type O, type A, and mutually exclusive. So you add them together. The second one, you want to find a probability that a type B or Rh negative. All right, so this one apparently is not mutually exclusive. Why is not mutually exclusive? Because if you add a type B together, you have a 45, right? And then if you look at the Rh negative, you also include 5. If you use the 65 in here, you already include 8. If you count this one is 45, you also count 8. So you count 8 twice. So you must, if you add a 65 and 45 together, you must minus 8 once, because this 8 was counted twice. Okay, so this one, the way you calculate this one here is you're gonna use 45 plus 65, right? But you need to minus 8 once. Okay, so that's 102. All right, so using 102 divided by 409. Okay, so that's about 25%. All right, if I add a percentage in here, that's about 25%, right? About 25% have a type B or Rh negative, okay? So because this is not mutually exclusive, so if you add a 45 and 65 together, you must minus 8 once. All right, so that is how you calculate mutually exclusive or not mutually exclusive in the probability, okay? Any questions so far for this section? Any question about the probability? Okay, so this is section some people find out a little bit challenging. Okay, so I usually recommend people say read the textbook at least once. All right, so that way you will combine like everything together. For that. Okay, it's like my PowerPoint. Don't erase everything I have in here. Okay, the good thing is with chapter 9. Okay, I have to figure out this one later to see why PowerPoint did not erase that one. Okay, let me save it into PDF. So open in a PDF. Okay, I don't have a 9.1 PDF in here. So let me save it into PDF to see if we can get rid of that mark. Okay, so the chapter 9.1 here is the good thing is this section is you can use all calculator pretty much to find out the correlation coefficient. Okay, so this is introduce the linear correlation coefficient independent event variable and how to find a correlation coefficient. All right. So what is a correlation? Correlation is usually trying to look at an independent variable and how did that affect a dependent variable, right? Like a x and y. But we don't really call them x and y. We call x is independent or exponential variable. Call y is dependent variable or called a responder out variable. Sometimes people also call the outcome variable, that kind of thing. Okay, and then we're trying to see, how x in affect y, right? So x is the number of hours you study math. Y is the test score. So we're gonna look at like how the number of the hours study affect the test score. So that would be kind of interesting right there, right? So some people even did a project before based on this one in here. Okay. You can look at this one right here. This is called correlation. This one, when x increase, y is also increase, right? So this is called positive linear correlation. And then this one, when x increase, y is going down. So this one is called negative correlation. And then this one, there's no pattern at all in here. So that's called not correlation, right? This one has a really good pattern, but it's just not a linear. Linear is a straight line, right? So this is called nonlinear correlation. So the good news is on these two sections, we only require the linear in here, okay? In this case. So look at this one right here. How do I construct a scatter plot using this one in here? Like this GDP in trillion dollars, and this is a carbon monoxide emission. Okay, so if the GDP going up, will the carbon monoxide also going up? Carbon dioxide. Okay, not monoxide is CO only, CO1. All right, so this is carbon dioxide, CO2. Okay, so is this one also going up? Well, it's kind of hard to do it just from this one. So we prefer this using the calculator. Okay, so we are going to use the calculator to input those data. So how do you input those data? First, you go to stat, edit. All right, and I already got a bunch of data right here. So I'm going to clear all of them out, right? So we clear all of them out. So we already know how to input this data before. Now we have to do the scatter plot. All right, so we usually like to input the x into L1, right? If I input x into L1, I don't have to change anything. Okay, so this is 1.8, 1.3. Okay, so that is my L1, and my L2 here is 604.4. Okay, so make sure your left side and right side are the same one. Looks like I have something missing in here. So you can tell my left and my right are not equal. So I have to check my number because it won't graph that way, right? So 6. The good thing is this one you can check it one by one. Okay, 604.43.44.37. Oh, I missed one number in here. Look at it. I missed the 742.3. Okay, and then that's 340.5. Okay, so now we have a left side and the right side the same. Okay, so now we go to do the second state plot. Okay, remember we have to turn the scatter plot on, otherwise the default is off, right? So we want the on is a highlight. Now the first one is the scatter plot. Okay, usually this default x default is should be the L1, right? All right, and let me go ahead and check it. Scatter plot. Okay, so I using the first one is a scatter plot. So my X list here is L1, my Y list here is L2. All right, and then I'll just go ahead and hit a graph. When you hit a graph, if you don't see anything, go to zoom, right? Zoom number 9 is zoom state. Now we can see this one. This is our scatter plot. Okay, so that should be a linear regression, linear relationship. So this one looks like a when GDP going up, you carbon dioxide, also CO2 also going up. All right. So that is the scatter plot we have in here. You can see this one is a positive linear correlation, right? And then we're gonna use an equation to describe this one. So that's our section 2, using the equation to represent this linear regression equation, right? So that's the GDP and then the CO2 emission in here. Okay, so this one you can see is very good positive linear correlation in here. All right, so this one is another student's GPA and hours of exercise, okay, in here. And then you can also, same thing, you can put this one in here. Okay, so how does this scatter plot look like to you? It looks like everywhere, okay? So we said this is not really not have any relationship, non linear correlation, okay? It didn't have any pattern at all. All right, so the number of exercise and your GPA is there's nonlinear correlation in here, okay? And then that is another one right here, the direction. This is Yellowstone National Park, that's world most famous geyser, right? The direction of several all faithful eruption and the times until the next eruption are shown in this one. Okay, so basically this X is continue on this X here, and this Y is also continue on this Y. So just this is trying to save space, so they put it this way. All right. So if you do the scatter plot, you can also look at the question in here. I want to look at this one is the correlation coefficient R. So R has a very, very complicated formula to calculate, but we are not going to ask you to calculate this one by hand. One thing is R can find that from the calculator directly, and I'll show you how to find the R from calculator in a minute, okay? But this R is between -1 to 1, okay? The correlation coefficient is between -1 to 1. If you have a positive 1, that means this is a perfect linear correlation coefficient, right? Everything line up very nicely. This one, this is going up, so R is positive 1. If everything line up very nicely by going down, R will be -1, okay? And there's no relationship, that means R will be 0, all right? So you can see this one R is 1, this one R is -1, right? This one R here is about 0.8 because you can see the positive relationship trend, but you can still see that. This one R is 0.45, so you can see a little bit pattern, but not very clear, right? And then this one R is so small, it's 0.04 because this one, the pattern is even weaker. And this one, the pattern is quite strong, but just not perfect. Okay, so R is -0.92. So you can tell like this is kind of an R relationship in here. Okay. This is showing you the step to find the R, but we are not going to ask you to calculate this one by hand. All right, so that's sigma X is the sum of the X value. This is the sum of the X times Y. So you must multiply X and Y for each pair first before you add them. Okay, so that is the correlation coefficient formula. All right. We're gonna use this one to find the correlation coefficient, showing you the step by step in here. How do you find the X squared, Y squared, how do you multiply them together? And then this is the sum of X, sum of the Y, sum of the X times Y, and so on, and eventually put it into this whole thing to do the calculation. So you have an R here is 0.874. This 0.874 is considered strong relationship, okay? Consider strong positive relationship in here. But like I said, we are not going to ask you. So let me show you how do you find the R in here. Okay. We're gonna go to the calculator, find the R. All right, I have this in here. I go to stat cal, okay, calculation. We're gonna using number 4, linear regression equation, because that's the one we're gonna using the linear. And my x1 is should be L1, okay. And then my y2 is y is L2. All right, so we're gonna just go ahead hit calculate. All right, this is giving you the linear regression coefficient y equal to ax plus b, which is our second section, the one we're gonna try to find. All right, so basically this one is 1.199.5346x plus b is 56.035 something, right? But this one didn't show the r, so in order to turn on the r, you go to second catalog. Okay, second zero is the catalog. All right. And then we're gonna go all the way to turn on the diagnosis. Okay, so go all the way here to diagnostic on. All right, so going down here and hit it on, and then hit enter again. And when this one showing done, and then we're gonna come back to do the linear regression, and this time it was showing you the R. Okay, look at that. Now we have this R here, the linear correlation coefficient. If I round to 3 decimal point, it's 0.874, right? 36, you round to this up, so 0.874, which is exactly the same we just calculate, right? Look at this one right here. 0.874, exactly the same. All right, so you round to 3 decimal point, you got exactly the same answer. So that is how we find the correlation coefficient from the calculator directly. So we are not going to ask you to calculate this one by hand like this formula did, okay? All right, so that is the correlation coefficient. Sometimes you can compare with the this one called a strong relation in here, right? And 9.2, basically, what does 9.2 mean? 9.2 actually is just trying to find a linear, the equation we have. Okay, so let's look at the last section here. It's called a linear. It's finding the y value using a regression equation, right? So this one is called a regression line. So we're gonna just drop a straight line in here, all right? And then you have a residual. Residual, that means it can be up or down in here, all right? And then we're gonna using mx plus b in the calculator using ax plus b. M is the slope, B is the y-intercept, right? There's also a formula to calculate this M and B, and that's very complicated formula, but we are not going to do this one by hand. As I said earlier, we're gonna do this one using the calculator. All right, so look at that. This is 199.53 46. If I using the calculator, I already have this one right here. Look at it. Do we got the same answer? 199.5346. We have this one in here. Okay. And then we have this B in here with all this big formula. But I already have a B here is 56.036 in here. All right. So I can go ahead and graph this one in here. Look at it. I can input this one. Okay, I can input this whole thing into my y value, and then we can graph them. So 199.53 535. Oh, 99.5. 535x, okay, and then plus 56.036. So when I graph this one right here, let's see what happened in here. Oh yeah, look at this line right here. This line is pretty much in the middle of all this scatter plot, okay? So this is called a linear regression equation line, or called base fit of the line. Look at this line is the base fit for all these things, okay? So that is the linear regression, and that is the equation we're looking for. So after we find this equation, and then we plug it into the y equal to, and then we can graph this line. All right, so this line fit all this data very well. Okay, so why we need to find this equation? Now we can predict. If I plug a different x value here, I can predict the y value. Okay, so that is called a probability prediction in here. All right, so look at this one right here. If I have a x is 2.29, I can plug it into the equation and then find the y value. So that is this section about in here. Okay, you can plug whatever the x value in here, and then you can find the y value. So that means the if you have a GDP is 1.2 trillion, right? So how much is carbon dioxide emission? You're gonna give you about like a 295.478 million metric tons. All right, that's a lot, that kind of thing, right? So if we want to go green, we have to consider reduce the CO2 emission, that kind of thing. All right, so that is predicting the y value, giving this linear regression equation. And as I mentioned earlier, we can all use this one, going to state, right? And then going to Q, and then going to number 4, linear regression equation. And that is how we calculate this. The linear regression equation also include the R in here. All right. So that's it. That is for all your unit 2. And the test is due by next Thursday, I think, according to the calendar. All right. So we are in the half semester already, because this is only 7 weeks. And then we are in a week 4, so that is half of the semester. All right. So hopefully you will catch up with the schedule, and then think of the good thing you're gonna finish just in a few more weeks, right? Like in a month, basically. All right. So think of the good thing and then study hard and in there. All right. Any questions? I'm going to stop the recording to see if anyone has any questions. Okay, so any questions about anything? If not, we have exactly the class time, just 9:50, so we will end the class. You can still send me the email if you have any question, but if you have right now, you can go ahead and ask her right now, okay? That'll be easier. Okay, anyone has any questions? You can even all right, if not, everyone has a great weekend, all right?
Thank you.
Thank you. Thank you for joining.